Hey everybody, hope you're doing well. I wanted to create and post my own video on at least this first section, but if I find that it's helpful to some of you, I can do it for every section in this Unit 9 on Ingenuity, but I wanted to make a video. The first section of the Unit 9 on Ingenuity goes through introduction of polynomials. And some of you have sent me an email or commented that you don't really like the videos or they're a little bit hard to follow. So I just wanted to do like a quick run through of what the goals are and some of this like key vocabulary in this first section, Introduction to Polynomials. So the first goal of the unit is to classify polynomials by degree. And what I don't think maybe they do a good enough job of in the video is explaining that we can have polynomials with just one variable, but we can also have polynomials with multiple variables. And the degree of the polynomial matters and kind of differs in definition, whether you're talking about a polynomial in one variable or a polynomial with multiple variables. So, for example, what I mean by a polynomial in one variable is something like this, where the only letter that I see is X. There's an X here, but I don't have any other letters. So there's one letter, one variable. In something like this, the degree is going to be the highest exponent of the one variable you're seeing. So this X has an exponent of 2. This X has an exponent of 1. So the degree of this polynomial would be 2 because 2 is the highest number. If we take a look at another example, now I'm using Y's, but the only letter I see in this expression is Y, so it's a polynomial in one variable. The degree of this polynomial would be the highest exponent of the Y. So this Y has an exponent of 5, this Y has an exponent of 6, this Y has an exponent of 10. The highest number in the exponents is 10. Now, if we're talking about polynomials with multiple variables, that's going to look something like this, where if I scan over the expression, I see X's and Y's, X's and Y's, X's and Y's. So this has multiple variables because there's both X's and Y's. To figure out the degree, you want to look at each term, and I'll talk more about this, but each term is going to be separated by plus or minus signs. So I have 4 terms here. What I want to do is look at the degree of each term. And in order to figure out the degree of the first term here, I'm going to add together the exponents of the X and the Y. So 3 and 5 is 8. Here, I only have one exponent. That's 2. Here, I technically have an exponent of 1. Again, when not written, you have an exponent of 1 and 1, so I want to add them together. That's 2. So the highest number out of all of these is 8. So this polynomial would have a degree of 8. If we do one more example like that, again, this is a polynomial in 2 variables because if I scan over the letters, I have Z and X, Z and X and Z. So I have multiple letters. I want to look at, oops, that's together, each term. So I have 1 term, 2 term, 3 terms. And I want to look at individually the exponents in each term. So here, technically, if not written, there's an exponent of 1. So the degree of the first term is 1. this whole thing here is the second term. So I have an exponent of 2 and technically an exponent of 1. So if I add them together, the second term has a degree of 3. In the last term, technically I have a 1 there and an exponent of 3. If I add them together, that's 4. So this polynomial would be a degree 4 because out of 1, 3, and 4, 4 is the highest number. So again, you want to evaluate when you're looking at a polynomial. Do you have a polynomial in just one variable or a polynomial with multiple variables? That I think is going to help you figure out the degree of the polynomial. The next thing is you want to classify, the next goal of this first lesson is to classify polynomials by the number of terms. So again, terms in an expression are separated by pluses or minuses. So if we take a look at the expression 3x plus 1, we have a plus sign. So it is separating the two terms in this expression. So we have one term, two terms. A polynomial with two terms is called a binomial because the prefix bi means two. If we have something like this, 3xy, I have no pluses or minuses. So I just have a single term. When you have just a single term, that's called a monomial. If we take a look at something like this, again, I want to separate the terms by pluses or minuses. So I have two pluses, which create three different terms. So 1's here, 2's here, 3's here. Three terms is called a trinomial, because again, prefix tri means 3. And then anything greater than 3, we're just going to classify as a polynomial. So this, again, if I separate with the plus or minus signs, here I technically have 5. We're just going to classify this then anything greater than 3 as a polynomial. Poly, prefix meaning multiple terms. The third goal of this lesson is to write polynomials in standard form. So what that means is you want to write the polynomial in descending degree order. So again, it's going to matter if we have a polynomial with one variable or a polynomial with multiple variables. So let's take a look at first if we have a polynomial with one variable. So again, I scan over the polynomial. All I see is the letter x, x, x. No other letters. So that's a polynomial with one variable. I want to write this in descending degree order. So what I want to do is I want to locate the term with an x that has the highest degree. So the x with the highest degree is the highest exponent, so 3. This x has a 2, technically this x has a 1, and the 4 has no x's attached to it. So I want to write the highest degreed term or highest exponent term first, and then go in descending order or decreasing order. So 3 was the highest. What's the next highest? 2 is the next highest. Took care of that one. What's the next highest? It would be x to the first power. Constants then are always going to go last. So this would be standard form of the polynomial in one variable. if we have a polynomial with multiple variables, so I scan over the polynomial, I have x's, y's, x's, y's, x's, y's, x. So 2 letters in the polynomial. I actually have different choices for how I write this in standard form. The first way is going to be by the x's. So because I have 2 letters, one of the letters is x. So I could take a look at the x values and write the terms in descending degree order based on the x's. So when I scan over the x's, which x has the highest exponent? The last one, x to the 4th. What then has the next highest exponent for the x's? That would be 3. So I'm going to write this entire term next. Which one has the next highest? That would be squared. So I'm going to write the exponent of 2 next. And then finally, technically there's a 1 here. That would be x times y cubed. Sorry, there's a lot of dogs in my house, and they are all barking at something outside. So the second way that we could do this is by the y's, because the other variable that we have are y's. So now if we take a look at the y values, this one has no y, we would want to write the y's in descending degree order. So which term has the highest y exponent? That would be a y cubed here. So I'm going to write that term first. What would be the next highest? That would be y squared. The next highest would technically be y to the 1st. And then last, I would put this one because it has no y's. So either one of these would be correct. Like this one with one variable, there's only one correct answer. But if you have multiple variables, you can base your standard form on either variable. So there are like 2 correct answers here. The last goal in this lesson is to simplify polynomials by combining like terms. So like terms have the same variables or exponents attached to them, and you're going to combine them by adding or subtracting the coefficients. So let's start out with something easy. If I asked you to combine like terms here, 3x plus 2x, these are like terms because the variables are the same, x to the 1st power, x to the 1st power. So in order to combine these, I'm going to add, because that's the symbol I have here, add the coefficients. So this would give me 5x. Now, if I change this now to 3x squared plus 2x squared, these are also like terms because I have the same variable with the same exponent, x squared and x squared, and what I'm going to do is perform the operation with the coefficients. So this would give me 5x squared. If I have something like this, I want to make sure that I look over because I have some different variables with different exponents. So the first thing I have is an x to the 1st power. If I scan over the rest of the terms, do I have any more like terms with the 1st? I do, because I have an x to the 1st power. So I would want to combine these through addition, x plus 5x, so technically there's a 1 in front here, would give me 6x. I'm then going to look at the x squared terms because these are like terms because I have the same variable with the same exponent. So I'm going to add the coefficients. 3 plus 2 would give me 5x squared. So when you're combining like terms, you want to look for terms that are like, that have the same variable and the same exponent. So all of these just had one variable, like x, 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 one letter. We also might see something like this, where I have multiple letters. So I have x's and y's running around all over the place in this polynomial. So this, I think, is a little bit harder to combine like terms, but we're going to do it the same way. So the first term, I have x squared and a y technically to the first power. If I scan over the other terms, do I have any more that have the same letters and exponents? Well, this is x cubed, not x squared. This is y squared, not y to the first. But this one, I have x squared, y to the first power. So I want to combine their coefficients. So technically there's a 1 out in front. So 1 plus 3 is going to give me 4. And I copy down the same variable and exponents. So I took care of the first term, took care of this fourth term. So I'm just going to cross them out to signal to myself I'm done with those. The next term is x cubed. So do I have any like terms with the x cubed? Well, this is y squared. No. This is negative y squared. No. So I'm going to copy it down, but I couldn't combine it with anything. And then lastly, I have y squared minus y squared. So same variable, same exponent. I want to perform the operation with the coefficient. So technically there's a 1 in front. And we want to do 1 minus 1, which would get me 0 y squared. So technically we don't need to include that because there's 0 of them. So that would be our final answer. So hopefully this video just kind of helps you understand like the 4 main goals of the Introduction to Polynomials lesson. I will post a PDF of these notes so you can take a look at them if they help you. Please provide me some feedback. If this helps, let me know. If you're still confused, let me know, and we will, try to figure out how to best help you understand this material.